Alright guys, what we're going to do right now is we're going to go over some electrical, and we're going to go over where you're losing voltage at. And this is important because when you put a meter on the system, you need to know how you will read voltage and why you will read voltage in certain areas. And I want you to understand that when you go to every system, they're all wired the same. No, they're not. They're wired different sometimes, because some of them may have a single pole contactor, some may have a 2-pole contactor, some may be wired with 2 capacitors in it. Okay, well, how do you do 2 capacitors? I'll show you. Okay, so you know, a lot of you new guys coming in, there's a lot of stuff I'm fixing to show you here. You have no clue about how you can do it and why you can do it. Okay, let's start out with the wiring of the system. On the wiring of the system, you have to know what some electrical symbols are, so you actually know what you're looking for. Okay, so what is this symbol right here?
It's a fuse.
It's a fuse. Okay, how about the symbol here? Open switch.
Switch.
Okay. Close switch. All right. What about this?
Resistor.
Resistance. Okay. What about if you do this? What is that? That's a relay, and this is your coil down here at the bottom. Okay? So you would have 24 volts going to your bottom, and then you would have normally closed between here and here because it connects. And then there's a normally open switch between here and here. Okay? So when you look at that relay, this may have number 1 on it right here, number 2, and number 3. So 1 to 3 is closed, 1 to 2 is open. So when you energize this switch, it energizes and takes this relay and opens it here and then closes it here. Okay? So this is my fan relay. So I will use this 9293 relay right here, and when I turn my fan in the cool mode, that cool mode is going to have high fan come to here and low fan come to here. And my voltage is going to come from the other side. So my common is going to be over here. This is going to be high and this is going to be low in this situation. Okay? You can wire this thing 1,000 different ways. What if I got one blower speed? I got a single speed blower. Well, how can I get my heat to come on if my heat is supposed to come from low? How can I get that to come on? Well, it's simple. I just take this right here. This is normally closed right here, right? And that's normally open. I take from here and I bring it to there. Well, that means that my fan is going to come on all the time, right? Does it? Yes, it does, if this is the case.
Yeah, because it's on.
One side.
Right?
Oh, right.
There's got to have something opening up that fan to where it's not running all the time. And if this is the case, if I'm going to do this, then this actually has to come down to an open switch and then come up, and this would actually be my heat sequencer. So when my heat sequencer closes for my heating element, okay, so if I have a heating element or a heat sequencer, and that heat sequencer has got this, so this is my actual heating element, and this is my load, 24 volts. So this switch right here, this right here would be, let's just say this one. So I'm going to erase this part of it right here, okay? And I'm going to go ahead and I'm going to bring this up to here, boom, to right there, and then that's going to come, boom, and then come down to here. So now, my fan motor will not come on because my voltage is coming from here, going to my low fan, going to my normally closed switch, going through there, coming up to a open switch, which goes to my high fan, which would then turn on, right? So I will supply voltage to my high fan right here because remember, I just said this is a blower motor that only uses 1 speed, okay? And I'm going to supply it up here when this closes, right? Okay? Well, what if I go turn my fan in the on position? It closes my high fan, my normally open switch. Will that turn my heating element on now? No, because voltage just comes right back over here. So this would be a heat sequencer, okay, heat sequencer. So here and here, I will bring voltage here at 24 volts in the common. And what is my 24 volt symbol here if this is a heat sequencer? Where does it come from a thermostat? What letter?
Oh, okay.
Or
W.
W. That's my heat. Okay? So this is my low voltage part of this and how we can actually bring voltage to this thing. Okay? Now let's go look at the high voltage over here. That'll kind of give you your relay a little bit that we talked about. We'll get more into detail on this in a little bit. Okay? So here I've got a common coming down to here. Let's see, that's my common. I've got my black coming in. They actually jumped it over. Now look, anytime you cross a wire, guys, if you cross a wire, your symbol on crossing a wire has got to go to that wire and jump the wire and then come down. That's how you know that wire does not meet. That's how you know it does not touch. If the wire goes across and does this, that means and has a little bitty knot in it, that's a wire nut. Okay? So, the black one would have normally came to all the black side, and your common goes all to your common side, okay? So here we got voltage coming from T1 to common, all right? So this is going to touch here to common. Boom. That goes on your capacitor right there. From common, there's your terminal, there's your other terminal. Remember, you got 4 terminals on your common part of your capacitor. On your hermetic part of your capacitor, you normally will have 3 terminals on here. Okay? So your start winding is going hermetic over to the start winding of your compressor. Your fan motor, your brown wire, comes down here and hits normally a single or a double on your capacitor for your fan, for your bringing your brown wire to your fan. Now normally that's brown. Could it be purple?
Mm-hmm.
Yeah, it could be purple. It could be yellow too. Okay? On some of the motors, on the replacement motors, you have to read it because sometimes you will connect the yellow and purple together and use the brown and the orange to go to common and fan, and that will make it spin counterclockwise. And then sometimes you will take the purple and the yellow and go over there and then match the other two, and it'll spin the other way. So reverse polarity will make that motor run different ways. You have to read the wiring diagram to see this. Okay? So here you go. L1, L2. You got 110 volts right here. You got 110 volts right here. In this case, in this scenario that we are looking at, we have a normally closed single pole contactor. Single pole means one opening side, the other side is closed, right? So right now we are bringing voltage all the way down here on my common coming down here, on my black one coming down here from my fan motor. So my question to you is, how much voltage? We're going to go ahead and we're going to do a common, we're going to do a ground wire over here, okay? So my ground wire is right there. So first thing is I'm going to ask you, because I have 110 volts here and 110 volts here, if I go from ground to here, how many volts am I reading?
110.
If I go from here to here, what am I reading?
110.
If I go from here to here, what am I reading?
220.
220, okay? What if I got 115 to 115, what am I reading?
230.
Okay? What if I got 70 and 115? Then what am I reading?
Right about 185.
No. I'm going to tell you, if you're reading 70 over here,
110.
210.
and you're reading 115 over here,
You only got 110. You got bad fuse breaker.
you got a bad connection somewhere.
Yeah.
And that bad connection is not allowing that voltage through, so that 70 volts. So if I did from ground to here and I'm reading 70, and I go from here to here and I read nothing, okay? You got a bad connection, not allowing voltage to get to it. And that's normally on the load side as opposed to the feed side, okay? So that's a little trick question in there, okay? We're going to open this up. It's a 2-pole contactor now, right? I'm reading how many volts?
220.
How many volts?
220.
0. It's an open contactor,
Okay.
okay? How many volts?
220.
How many volts?
110.
Nothing. 0.
0. How many volts?
0 again.
How many volts?
220.
How many volts?
0.
0. Okay. Close one side of it. How many volts?
220.
220.
How many volts?
0.
0.
0. Because I'm not feeding back in order to read the other side, so therefore I have nothing to measure it with. So I'm reading the same leg. That's what it boils down to. I'm reading the same leg. Okay? How many volts am I reading?
0.
How many volts am I reading?
110.
How many volts am I reading?
0.
How many volts am I reading?
0.
How many volts am I reading?
110.
110. How?
It's going all the way.
It's going all the way through the system and coming back around the other side. Okay? How is it doing that, guys? Think about this, all right? Let's follow it. My voltage goes from here to my capacitor, through my capacitor, through to my common. Well, there is a winding in between here, isn't there?
Yeah.
Okay? Well, if there's a winding in there, that's resistance, right? So my voltage goes ground, 110, 110, 110, 110, 110, 110, 110, 110, 110. Everywhere. Why? Because voltage goes through it and follows all the way around, right?
Yeah.
Okay? So when we get to an electric heat system and I do this same thing, and every time I go to electric heat system, you do not take this lead and put it on the ground. You do not do that. If you do that, you will screw everything up and you will have no clue what you're doing. One lead stays on L1 all the time and never leaves it. The other lead goes to L2, or vice versa. One of them stays, the other one travels. Okay? That's how you find an open circuit. Okay? So here's what I'm going to do. I broke your wire. Okay? Follow this. Ground. How many volts?
110. 110.
110. 110.
110.
110. Other side.
110.
No, nothing.
0, because I broke it and the voltage cannot go over there, right? Is there any other way I can get voltage to follow back around?
No.
It's not connected, is it?
No.
Is there voltage maybe going from here to here to get to here and here to here? Through your
Unless you have a
capacitor?
wire connected from your common to your motor.
Well, there's resistance in between there, isn't it?
Yeah.
There's your capacitor, your microfarads. So am I reading, can I read voltage? Well, if I go from here to here, will I read any voltage?
Yeah.
Yeah.
To be perfectly honest with you,
I would say.
I don't know 100% if the answer is yes or no. I'm going to say that you will probably read voltage from here to here and going through it with the microfarads. I'm not 100% correct because I've never tried that. Because I've never had a broken wire there to do it. Thinking about it, you know. So we will test that. How about that? We will pull one off and see if you go from there. But I'm
I
going to
would
say you
think
probably
no,
will.
but
Yeah, we will see. Do you read the voltage through the capacitor with voltage to one side of it? So if I pull all the wires off of it and I bring voltage from here to here and I take these wires off, will I read anything from ground to common? I read 110, but will I read anything there? I don't know the answer to it, to be honest with you. Something we'll have to find out. Okay? So, all right, let's close this wire back again, guys. Okay. I'm going to turn the system on now, so that closes my other contactor, right? Okay. I'm gonna go, tell me how many volts I'm reading.
220.
220.
Okay, I'm gonna keep one lead on here, right?
Uh-huh.
Then I'm gonna go from here to here.
Still should
220.
read 220.
220. What about here?
Same.
Same thing.
What about here?
Same thing.
110.
0.
Oh,
Zero.
yeah, same line.
Yes, sir.
Zero.
It's
yeah.
the same
Same
line.
Mhm.
Okay? Anytime you read the same line, it's 0. What is your dividing point? Your dividing point is your load. Okay? That is your dividing point. So, your separation between line 1 and line 2 is a load. What's your separation between line 1 and line 2 now?
It's the load.
Contract.
Oh, the contact.
Okay? It's your contactor.
See, more-
What's the separation between line 1 and line 2 now? Still your contactor, right? So if you think about it, again, how many volts?
110.
How many volts?
110.
How many volts?
110.
110.
Wait a minute. So if I got 110, 110, 110, 110, my system should be running, right?
No.
No, because you don't have 220 and 220, right?
Right.
So are you trying to check a 220 system here or a 110 system?
220.
220.
So why would I go ground to anything? I wouldn't.
No.
What are you looking for? Always looking for 220.
You're always so my point in trying to discuss this with you is when I go to ground and I go 110, 110, 110, 110, 110, 110, 110, 110, what did I
Waste
find?
of time. Nothing.
I found I didn't find anything. Okay? So 220, anytime you got a 220 volt system, you go 220. If I got a blower motor, I'm reading 110, I can go ground, and I can go 110, 110, 110, 110, 110, 110, 110, 110. Okay? Well, now what if it goes 110 all the way around and that motor's still not running? Then what could be my problem? My ground's not grounded. My common's not being a common. So I may have a ground here that I go 110, 110, 110, 110, 110 all the way around, but I don't have my common to my motor or my, it's not grounded some kind of way shape or form, so it's not running. I don't have a common to it. What's the difference between a ground and a common? What's the difference between
Common,
a ground?
it always has power to it.
No, a common does not have power to it.
Not,
If you got a panel and you got your ground bar on the side over here, right? And you got L1, L2 coming in, right? You got a breaker here, right? Double pole breaker. Double pole breaker hooks here and hooks here, right? So now I got 110, 110, right? That feeds 220, right? On that double pole breaker. I got a single pole breaker right here, let's just say. That one's bringing 110 because it's going to connect to the next pole, let's just say. Well, right there, okay?
Right.
So I got 110 coming in. So now I got a number 12 wire coming in, and I got a black wire, and I got a white wire, and then I got a ground wire over here, right? Where's my ground wire go?
To the bottom of the back.
To the ground. Okay? Where does my white wire go?
Common.
It goes to this bar over here. Okay?
Neutral.
This is my ground bar. This is my neutral bar because there's another white wire coming in here and it goes to neutral.
And ground and neutral in the same spot on the
And
box.
then this bar connects to this bar.
Stay in the same spot on the box.
Okay? So my question is, my black wire ties here, right?
Mm-hmm.
That's my 110 volts on my black wire. Where does my white wire tie to?
To the neutral ball.
To the neutral bar, right? Can I tie it over here?
You can, but you're not supposed to.
Can you tie it over there?
They're tied together in a no. Tied together in a
Yes, you
box.
can. Yes, you can do it.
Yes, you can do it because it is connected to the bar. You can do
Stay
it.
in the same spot.
So what's
the
the
back of
difference?
the box?
My ground bar
You're not
is
supposed to.
grounded in the ground. My neutral bar is not grounded in the ground.
Oh.
So a ground is grounded. Okay? They are connected though, aren't they?
Yes.
So let's just say I have a wire coming into a system, okay? And I've got my black wire, my white wire, and my ground wire, okay? And I go from white to black, and I read 70 volts. And I go from ground to black, and I read 110 volts. What's my problem?
Brown to black, I mean.
Ground to black, I'm reading 110. White to black, I read 70.
Yeah, loose connection.
You got your neutrals.
I got a bad connection on my neutral. Okay? Well, wherever it's wire nutted to back here, some kind of way, shape, or form, it may be a switch. It may be a ground fault somewhere or whatever. I mean, there's a bad connection somewhere that here's what happens. Let's just say is the case for argument's sake that this is a good connection. It's solid. Okay? And let's just say for argument's sake that this is a bad connection because you barely got a little connection right here. Okay? So what happens is when that load comes to it, it heats up right there and you lose the voltage. So you know what's going to happen? You're going to walk up to this system and with a load on it, you're going to read 70 volts. And that motor's not going to run because it's a 110 volt motor, right? But you're going to turn the system off and you're going to go 110 volts. And you go, damn, I got 110 volts to it. Why is it not running? You're never going to check it with the load on it. You turn the blower motor on, it don't run. Turn the power off to the system, you move your wire nuts out the way, right? And you go, huh, I got 110 volts. Put the wire nuts back on it, right? You turn it back on. Blower motor don't run. You go, I got to have a bad fan motor, right? I got 110 volts. So you go get a motor and you put a new motor on. You turn the system back on. You put your wire nuts back on. Turn it on. Motor don't come on. Damn, I got another bad fan motor. All right, let me go get another motor out my truck. You go put another motor on. You turn the motor on. You go, damn, I got 3 bad fan motors. Brand new out the box.
Something needs to go boom.
Some light needs to pop up somewhere. Somebody needs to slap you with a common sense stick. You know? So what's happening, guys, as soon as the load comes to it, the voltage drops down and the motor don't turn. So what you need to do is you need to take your wire nuts off and you need to put a load to it and then you need to see what your voltage drops to. Now you know the motor ain't running because your voltage drops. Okay? So if I got a bad connection here, alright, I made a bad connection right there. And that compressor don't come on, right? Or if I got pitted up contactor points right here, right? I got little ants that crawled up inside of here. And it smushed the ants. Is it still making contact? Yeah. It's getting voltage. You know how it's getting voltage? It smashed the ant. So it's still getting some voltage across there. So when you put your meter on it, you're going to go 230 volts. You might have 180 volts. And you go to the other side and you might read 240. So do you hold the same voltage at this side of your contactor as you do at that side of your contactor? How many people ever check it? Check your voltage. See if you have a voltage drop across your load, across your contactor, where it meets. Okay? If you don't have the same voltage from one to the other, guess what you need to do?
Replace that part.
Replace the contactor. Okay? How many volts do I have right now? My system is energized and it's running right now. How many volts do I have? Common, pneumatic. How many volts?
220.
How many volts?
110.
110.
How many volts?
0.
How many volts?
0.
Alright, we went 220, 110, and 0. One of them's got got to be right, right? Wrong.
No.
It's a 440 volt
440.
contact capacitor. How many volts am I reading between common and hermetic?
440.
440 volts. Who wants to touch it and figure it out?
Not me.
It hurts.
Oh yeah.
It makes you dance. Okay? How many volts am I reading between common and fan?
Same thing.
440 volts. It is a 440 volt capacitor. It reads 440 volts. Have you ever tested it? Have you ever put a meter to it to see if that's correct or not?
I don't know, but I've had one blow up in my face already.
So, 440 volts. Why does that compressor not fry with 440 volts going to it? Alright guys, you have 440 volts to your common, between your common and your hermetic. And that will actually hit that start winding. So your 440 volts is going to your start winding, which is actually popping that compressor into gear and helping that compressor go from start to run. Alright? So start amperage on a system is 5 times the run load amps usually. Okay? So if you can lower your start amps on that system by adding a hard start kit to the system. Well, what is a normal hard start kit? A normal hard start kit is a KS1 or a T-5 that comes standard of just 2 wires, right? Well, our 2 wires do what? Here's our hard start kit, right? Our 2 wires that go into our little box with our capacitor in it, right? Okay? So your little wires are tied up into a potential relay and start capacitor up inside there, right? There's your hard start kit. What is your hard start kit doing? It's adding additional voltage in between here, which is popping your start winding and popping that compressor into gear. Okay? If I add 220 volts to your ass, will you get up? Okay? Well, what, will you get will you get up a little bit higher by adding 440 volts to your ass? Okay? So your hard start kit pops that winding and pops it into gear. So here's what can happen. Okay? I have voltage to my common, right? And my run, right? So here's what I want to do. I want to blow this capacitor right here. So my capacitor right this second is blown, okay? So it's swollen up, all right? If my hard start kit is not there, will that system run?
No.
No, it's not, because you're not going to get the voltage from common to hermetic to start that system. That's what's not going to happen. It is not going to run. But now, I just bypassed it, and I put a hard start kit on it, and I popped that compressor, and I hit that start winding with extra 350 volts. Boom! Will that compressor start and run now?
Yes.
It's going to run, and it has a blown capacitor on it. Swollen up capacitor blown. You know it's bad, right? It's got a hard start kit, and that compressor is going to kick on and run because I am putting voltage to my common and run and making it run. But it will not run unless I pop the shit out of it in my start winding. Well, the capacitor, the run capacitor, does it normally. Blow it out, put a hard start kit on it, it'll run. So when you get there to that job and you see somebody has put a hard start kit on that system, does that mean you should not go check the capacitor?
No.
That means you should go check the capacitor because the dummy before you didn't check the capacitor. He just put a hard start kit on it. That's what you're going to find 80% of the time. Okay? I find that all the time. Blown capacitor. I mean, it's like non-stop I find that. Especially older systems. And that blown capacitor may be blown for the last 3 or 4 years. Somebody put a hard start kit on it 3 years ago. And it's been blown for 3 years and it's been starting just like that for 3 years. So when you get there, you find a blown capacitor, put a new run capacitor on it, and it will lower the amperage. Okay? It will lower the amperage. Alright? My condenser fan motor, how many volts am I running on the system right now?
0.
220.
220 volts.
220. So
Okay? Between here and here.
440.
440 volts to start that fan motor. Well, what does your capacitor do for your fan motor, guys? It does the same thing, right?
Same thing.
Adds extra
Works
voltage to it so it can start. How many times you get to a fan motor and it don't want to start? Okay? You got that capacitor, right? Well, what is your capacitor doing? Adding 440 volts to the starting of that fan motor, right? So it'll start turning. If every time you get to a fan motor and the fan motor doesn't start, does that mean it's a bad capacitor? No, it could be bad windings. Could be bad bearings in the motor. The bearings are too tight and the motor don't turn. Okay? So, electrical guys, you got to understand it. You got to understand how your wiring goes and how your compressor goes. And what color wire is this? What color wire is that? Run.
It's a red wire.
It is a red wire. What color wire is this one?
Red.
Black.
It is always a black wire. Going to common. What color is this wire?
The orange wire.
It is a black wire.
Black.
Okay? What color is this wire from start to hermetic?
Orange.
Most of the time?
Some yellow, blue.
I think it's orange.
It's not orange. A lot of times it's going to be yellow or purple or it's going to be that little different color. Now, is your purple wire bigger than your black wire or is your black wire bigger than your purple? And is your red wire the same size as your purple or same size as your black or is it a different size?
All three of them are the same size.
Nope.
No, the red and black coming off your T1, T2 are bigger.
Yes. Your red and your black are bigger and your purple is a smaller wire because they don't have much amperage going to that particular wire. Your start winding doesn't hold a lot of voltage. It doesn't hold a lot of amperage, excuse me. Holds voltage but not
High
amperage.
volts, low amps.
So a lot of times it might be a yellow wire, it might be a purple wire going to your start. So when you look at your old start capacitors, the purples are going to the hermetic. Your number 2 is going for your start relay is going to your hermetic, you know. So they will color code it as well. Okay? So you gotta look at that kind of stuff. When they do it from the factory, they color code it. And they color code it for a reason, so that you don't mess it up. What if they just went and put any wire anywhere? And then every wiring diagram was different. It's pretty stupid, wouldn't it? Okay. If I put my amp probe right here, and I'm telling you, there's my amp probe, and I'm telling you this system, when this system runs, it draws 10 amps. And I'm telling you when it starts, it draws, I don't know, 100 amps, I'm just going to say. I'm going to make that up, okay? And I put my amp probe on this red wire, and it's running right now. How many amps should this system be running?
10.
Should it always be 10?
No, when it starts, it's going to be 100.
Okay. For how long would it be 100 in this case, for argument's sake?
2 seconds. 2 seconds.
Just a second or two, just that long, actually.
That's the start.
Just to start it. Now, what's wrong with my system? Because I'm telling you right now, I'm not drawing 10 amps, I'm drawing 7.2. What's wrong with my system, or is there anything wrong with my system?
You could be low on freon.
What else?
Just don't have that much heat load on it.
Hey, you have a low capacity. So you know what the 10 amps is telling you? Full run load. FL. Full run load. Okay? Full amps. Okay? Lock rotor amps. It's locked up basically. Okay? Hard start kit gets it out of the lock rotor. So if I put a hard start kit on it, would it draw 100 amps anymore?
No.
No. It might draw 25 amps when it starts. It might draw 12 amps when it starts. Okay? But just because you're not drawing full load amps, it's not 900 degrees outside either.
Right.
It's 72 outside and 71 inside. So it's not going to draw full load amps. Okay?
It'll be running
FLA.
lower than 7.2.
FLA means what? Full load amps. Okay? What else here, guys? What if you got a fan motor here, that the fan motor has got this wire, and this wire, and this wire, and this wire, and these two are connected, and these two are connected. What are those wires for?
Reverse.
Reverse polarity. Okay? So, let's just say right now it's running counterclockwise. How would you make it run clockwise?
To separate both them wires.
Okay, I separated them. Now what do?
Okay. You take one of them. It's normally a purple and an orange, or you take the two top ones, hook them together, and the two bottom ones, hook them together.
Okay. All right. So two top ones together and two bottom ones together, right? All right. Reverse my polarity. Now those wires also come with it. You can't screw this up. Those wires come with a male and a female, and a male and a female. So you can't now hook this one to that one when it should be hooked to this
Right.
one. So that's a good thing. Okay? They don't just come with wire nuts, so you can make it on any of them. All right? Let's see what else, guys. If I've got a 440 volt, 50 microfarad capacitor, then I should have a 440, 50, and let's just say it's 5. Okay? And I'm reading 3.2 on here, and I'm reading 42 on here. What should I do?
Change it.
Change your capacitor. Okay. I'm going to look in my truck, and I have a 370 plus 50 plus 5. Can I use it?
Yes.
No.
No.
You can't lower the voltage.
It's a full order.
All right. What if I have a 440, 45 plus 7.5? Can I use it?
Yeah, but I wouldn't leave it on there.
No. Because now you're going from a 5 microfarad capacitor to a 7 microfarad capacitor, and you're going from a 50 to a 45.
You can go lower, not higher, right?
If you go lower, will it work? If I go from 50 to 45, will it work?
Sometimes it will.
Yeah, it will.
Yeah.
Yeah, it will. It will.
It'll get you out of bond, but
It'll
it
get
won't
you out of
leave
bond,
it.
but you need to go back tomorrow and you need to put the correct capacitor on it, okay? Now, if I go from a 7.5 to a 5, will it make that motor work? No, but if I go from 7.5 to a 10, will it work?
Yes.
It would. Okay, again, I don't want to leave it on it. Now, if you look at the motors are going to tell you sometimes put a 7.5 if your voltage is this, and put a 10 if your voltage is this. You got to read that stuff. How do you know? Okay, so it's going to tell you on the new motors you've got 1/3 horsepower. It tells you a 5 microfarad capacitor. Half horsepower, 10 microfarad capacitor, 3/4 horsepower, because you got a motor that does all different horsepowers, and it gives you different capacitors for each one of them as well. Okay? So you got to look at that too. You got to read these boxes, which we're going to give a class on these motors, so that you guys, when you're going to change a motor, you're not confused with it. Okay? That's a good thing, Questions on any of this, guys? No? Well, this is one class that we're doing here on electrical. We're going to follow this up with some more classes on electrical, because I really want you guys to understand electrical. We did some other classes, superheat, subcooling, service tickets, the whole 9 yards. Watch some of these other tapes so that you guys will understand the total 9 yards of this business. I want to thank you guys for actually coming in today on Saturday and learning this stuff.